Hey everybody, we're continuing with number 3, and we want ds dt if you have s equal t over 7t plus 2. Now, in that last video, I said we may end up having to do this the long way, which is still doable, but I just remembered a second shortcut. So the main thing is to start with, we bring this up, and so it'd be 7t plus 2 to the negative 1. Now the shortcut I'm going to talk about is called the product rule. And so it's basically, if you have u times v, that'd be u times the derivative of v plus u prime times v. So in other words, keep one of them the same and do the derivative of the other, plus keep one the same and do the derivative of the other. So that is what we want. So I'm going to call this u and this v. So if I keep u the same, that would be t, and I want the derivative of this. So I bring down my power, so this is negative 1, and then I have 7t plus 2, and then I lower it a power. Whoops, this was 7t plus 2. I lower it a power, and then I need to multiply by my 7 because that was the derivative of what's inside. Then for the next part, we say plus. The derivative of u is just 1, and then we keep this the same. So when we rewrite this, this is going to be negative 7t on top, and 7t plus 2 squared on bottom, and this would be 1 over 7t plus 2. What we need to do is make this be a common denominator. So I'm keeping my numerator part on the left the same, but on this one I've got to multiply by 7t plus 2. And now when I do that, I can combine my like terms and these cancel. So you get 2 over 7t plus 2 squared. So that's what we want. 2 over 7t plus 2 squared. Okay, so that's number 3. I'm going to go over that one more time just inside here. If you need to fast forward, you can, but some of y'all probably didn't catch that the first time, because it is the first time for you to see it. So that was the product rule, which is uv equal uv prime plus vu prime. And what we did is t negative 1, 7t plus 2, negative 2, and 7, plus 1, 7t plus 2 to the negative 1. So then this side became negative 7t over 7t plus 2 squared, and this side became 1 over 7t plus 2. So then I'm getting a common denominator between these. The negative 7t stays, and I do 1 times 7t plus 2. So negative 7t plus 7t cancels, so I get 2 over 7t plus 2 squared. and that's your answer. Okay. So now on this one, the derivative of 2x is just 2. That's for this part. And then this one we're going to have is 5x to the negative 1. And so when we take the derivative of that, 5 times negative 1 is negative 5x to the negative 2. And so then you put these together and it becomes 2 minus 5 over x squared. Now this one has 3 and then x plus 1 to the negative 1/2. The reason why it's a negative is because I'm bringing it up, and so it's a negative. It's a 1/2 because it's a square root with root 2. Now, on this one, we bring our negative 1/2 in front. We keep the x plus 1 the same. We lower it a power, which becomes negative 3/2, and we take the derivative of x, which is just 1. And we still have that 3 in front. So this is negative 3, and then this is 2x plus 1 to the 3/2. And then we rewrite that to be negative 3, 2. Okay, so I'm going to take my time and call this x plus 1. And then the other part is going to be this to the 1/2. Because remember, 3/2 can be broken up into a whole plus a half. And then this gives you negative 3 over 2 x plus 1 square root of x plus 1. Negative 3, 2 x plus 1 square root. Very good. Okay. Now, this particular one is probably the easiest because if you have t cubed minus 2t squared, you take your 3, bring it in front, and lower a power. And then 2 times 2 is 4, and then lower a power. Really? That's funny. So this says minus t squared, and I put negative 2t squared, which makes this minus 2t. Okay, well that's easy. That really is. So then we want our slope at the particular one. So you're going to do your dy dx calculator part with position 3. So we go into the graph, 3x squared minus 2x. Okay, there it is. Do your analyze, do dy dx, and it's position 3. And so I get 16. Hold on just a minute. X to the 3rd power minus x squared. Okay, I get 21. Okay, so what we need is put x cubed minus x squared, and then we do dy dx, and then position 3 gives you 21. So there's the 21 right there. So just because you have an answer here doesn't mean you should use it. You really should not. So don't use 3x squared minus 2x in the graph with the position. Use the original. Okay, on this one, we've got 7, and then I'm going to write this as x minus 1 to the negative a half, because we're bringing it up, and it looks like that. We do keep the 7, and we bring the negative a half here, and we go x minus 1 to the negative 3 halves. And then the derivative of the inside would just be 1. So what we do is we get negative 7, 2 on bottom, and then x minus 1 to the 3 halves. And like that other one, we want to break that up to x minus 1 and then square root of x minus 1. So negative 7, 2 x minus 1, square root of x minus 1. Notice these have the negative to the side, but I prefer it to the top. But it would still count it right. If you only have a single number in your numerator, it would count it right. Now it's going to want the equation of the tangent line at that particular point. And so we use our original. Okay, so the original 7 over the square root x minus 1. Okay, there it is. That number was just random. That's why sometimes I just do a new document, because I don't trust that number. It's blocked. No. So now what we want is position 2. So menu, analyze, dy dx, position 2. That gives me negative 3.5. And then if you go over here, negative 3.5, menu number fraction, that's negative 7 halves. So that's your slope. And then you do your y minus y1. Well, actually, let's just say y equal y1 plus m times x minus x1. Your y1 is 7. Your m is negative 7 halves. And then x minus 2. So this can get rewritten as negative 7 halves x plus 7, because negative 7 halves times negative 2 is positive 7, and then this gets combined, so it's negative 7 halves x plus 14. So I hope it doesn't bother you that I put y1 in front. You could put y1 in back, just say plus 7, but the math would work out the same way. So there you go for number 7. For number 8, this one's probably like one of the easy ones, I think, if I remember right. You want to do 5 minus 2x squared, and then you go to position -4, then your answer is 16. So this was menu, analyze, dy dx, and then position -4, because the -4 is what's listed there. And then that gave you the answer 16. So same thing here, except for make sure you use y and x. Or y1, f1, whatever, f1, y1, whatever. It's all the same. 5 divided by the square root 11 minus x. So there it is, and we want to use position 2. Oh no, which one was it? I need to do a new document part. So I'm going to be lazy or efficient, whatever you want to call it. Since I'm redoing it, right there I'm going to hit Control A, and then I'm going to do Control C to copy it. And then I'm going to do my new document, add graph, and I'm going to paste it in there. And then I need to get rid of this extra f1x, because it would say something like recursive. Yeah. You don't ever leave it as both of them. Okay, so there it is, without the number. Okay, so then what we want is menu, analyze, dy dx, and then the position I want is 2. So that's my answer, but I need to copy it and make it show up over here as a fraction. Ooh, that's yuck. That's not any good. In my notes from years ago, I had this, and so I used 2 over this, and I had to use position 0. But your position is 2. Let me check this out. Oh, you know what? What I noticed is the very last number is a 3. And, you know, when you start writing things, sometimes you can see a pattern, like 925, 925, 925. Well, this 3 was rounded. That's really 925. So really what it looks like is 0.0925 repeat, just that part. I mean, don't repeat any zeros. 925, 925, 925, 925, 925. Okay, menu, number, fraction, 5/54. Mic drop. It's all good when it works out. Okay, now on this one, we're doing the derivative of this. And when we're taking our derivative, then we do the exponent times 2, so that's 4x, and then this one's minus 1. Oh, that's it. That's simple. On this one, I know one year students just started figuring out, oh, put a negative and put it squared. But the reason that works is because your function is 6x times x minus 1 to the negative 1. So if we use our product rule, we're going to keep the 6x the same. We're going to start taking the derivative of this part, which would be negative 1 x minus 1 to the negative 2, and then times 1, plus, then we take the derivative of the 6x, which is just 6, and then keep this one the same. Now we have to rearrange this a little bit. This would be negative 6x over x minus 1 squared. So what I did is I moved it below, and 1 doesn't matter. That's just negative 6x in my numerator. And then on this part, I have 6 over x minus 1. Now I need a common denominator. So x minus 1 squared. Keep this negative 6x and make this 6 times x minus 1. So that would be negative 6x plus 6x minus 1 over, 6 times negative 1 is negative 6. So right there. And then x minus 1 squared. So then this goes away and you have negative 6 over x minus 1 squared. And that does match this. So there's the math for it. But yeah, I do remember students figuring out patterns like if it's 6x, then this will be negative 6, and then put this squared. Try it out. Test it on the homework before you just check it on a test or something. Number 12, this one we have f equal 3 plus 7x to the 1/2. So for f prime, the derivative of a number is just 0. This part we put 1/2 in front, then 7x, and lower it a power, and then your derivative of 7x is 7. So this would be 7, 2 on bottom, and then square root 7x. And sure enough, that worked out. These are derivatives. Derivatives means it's a lower exponent than the one before. Okay, now you have some graphs, and this is actually very, very general. So basically, if it's like that, that looks like x cubed. And so the derivative would be like x squared because it's lower 1. Now, if it started like this with a parabola, then that'd be linear. So just got to be general. I know it had some translation parts, but that's how you do it. So this looks like a negative x squared part, so then our derivative would be like negative 2x. So that's that. And then, okay, here's an example of one where this says blue and this says red, but we're in black and white. So Anyway, your original is going to be the same shading, which is all of them. And then the derivative of a parabola would be a line. Well, this line is horizontal. This one's tilted, which is what you want. Now, the other way is this looks like exactly x squared, and so we get 2x. And you know it goes through 0, 0, 1, 2. Let's see, we're counting by twos. And then, so 2, 1 would be right there. That's exactly right. Okay, that's 15. Is that all of them? No. Okay, this one's like a paragraph. We want to know about the -2, 6. At what points is it not defined? Well, on our original notes, we said any sort of cusp or corner. So 0, 1, and 4. So those are your corners. And then it wants the derivative. This is the horizontal line, y equal 1. This is the horizontal line, y equals 0. And this is just a random point that looks like y equal 4. Okay, so what we're first going to do is figure out what this equation is. And for the front, or the left, this is rise 2, run 1. So that's 2x. So our y prime would be 2. Now, did I do that right? These are counting by twos. Rise 2. Oh, you know what? It's rise 2, run 2. But the scale is all different. Because it's only one box over, but it's 2 units. And this one's literally counting by ones. But we went up to right 2. Up to right 2, which means slope is 1. Which is why this ties into y equal 1 for that part. Now on this part, we're going from 2 to -5. Means down 7. And we're going right 1. So that'd be -7. That's this part right there. And on this next part, we're going right 3. I mean, we're not going up or down any. We're going right 3. And so that's why that part's 0. And then for this one, we're going from -5 to 2. So that's up 7, right 2 in this case. Up 7, right 2. So that's 7 halves, which is 3.5. And I wasn't totally sold on y equal 4 because it's not there. It's like barely under 4, which is like, 7 halves or 3.5. Because it's not actually on that line. So I get that. So the thing is, figure out the slope of each one. The slope of each is a horizontal line. Okay, then 17, you got a word problem. We care about the GNP, or gross national product, for these years, and we want the correct derivative. So for this little section, we're going up to right 1. So that's slope equal to. So that means your line would be y equal 2, which is that part. And then for this part, we're going down 1, 2, 3 units and going right 1. So that'd be slope of -3. So for the y prime line, that'd be -3, which is why this went down. And then this one, you're going back up, same amount, up 3, right 1, m equal 3. So the y prime line would be 3. So higher than the 2. I mean, it all works out. I mean, anyway, that's going to be A. Okay, and then our last one, we start with x cubed over 9. And I'm going to write that as 1/9 x cubed. That makes me feel better. That's my function. So then for my f prime, we bring the 3 in front, keep the 1/9, and lower this to x squared. So that'd be 3/9 x squared, which is the same as x squared over 3. And that's what we have here. Then they just want you to graph it. And the original one is cubic going forward. And so that's this 1b. Because this is going backwards, it's not D. This is going forwards, but then your part here is down instead of up. This means up because it's positive. This is going backwards. Okay, and then your verbal, whatever, your written explanation, it's bigger than 0 for x less than 0 and greater than 0. It's f prime equals 0 for 0, and it's not negative for any value because we're not below the x-axis. And then it increases as x increases for everything. It's greater. Okay, hope that helps. Wasn't perfect, but getting better all the time. Hope you have a great day.